Hello and welcome. I am Professor Doobie, and today's lesson is on recognizing the graphs of 7 of the more common functions we run into in mathematics. I'm using Desmos to graph the functions to demonstrate them, and the idea is you would recognize the shape and the equation that goes with that shape, so that if you're given an equation, you have some idea what the graph looks like without absolutely plotting points and sketching it. So the first one is right here, and it's f of x equals 3. Now remember, f of x just is, here are the instructions, how do you find y? So for this graph, y is always equal to 3. That has the effect of giving us a horizontal line. So our first function is whenever f of x equals a number, we should recognize that the shape is a horizontal line. Now students tend to call this a straight line, but I will point out that all lines are straight. This one is a flat line. It has a slope of 0. So on to our next function. I'm going to shut off the first one. Now we have f of x equals x, or y equals x. That also is a line. And it's a line such that every y coordinate is equal to its x coordinate. So when x is -1, y is -1. When x is 1, y is 1. When x is 5, y is 5. When x is -5, y is -5. This gives us a slope of 1, and this is an odd function. And if you think about even and odd functions, our horizontal line was an even function. But this is pretty basic. Now you move this around probably when you study lines by putting numbers in front of the x and numbers after the x to move it up and down, numbers in front to make it steeper or less steep. So we will look, looked at this kind of a function and how it moves around already, but the most basic line, and this is called the identity function also. So y equals x is a line with slope 1, also called the identity function. The third function we'll look at is y equals x squared. It's over here. And this one is called a quadratic function. Any function with the highest, any polynomial function with the highest exponent of 2 is called a quadratic. This is the most basic quadratic. What you should recognize about this is that it is a U shape, and this one's pointing upward. We haven't started moving any. We're going to move these around in future lessons, but it's got symmetry over a line that goes through what we call the vertex, and it's rounded. The rounded is important because that's what makes it different than the absolute value function. And the reason that you get only positive y values for the function x squared is because when you square a number, let's go to the point where x is -2. When you square a negative number, you multiply it by itself. You multiply two negatives together, you always get a positive. So whatever you get at x is 2, you also get at x is -2. They're both positive values. Squaring a number kind of takes away what its original sign was. You don't know whether it was positive or negative because it always comes out positive. So that's y equals x squared. It's very important to recognize this. We will move it around some by putting numbers in front of it. You can see it make it steeper, or by adding numbers to it. Oh, I should take a number away so you can see it. So I'm going to subtract a number from it, moves it down. And then if I decide I want to put something in with the x and square it, it will move it to the side. We will look more at those movements. For now, your mission is to recognize this shape as being the basic function x squared. The next function is very similar to what we just looked at because you see the symmetry, but notice there's no roundness to it. It's really the two lines. It's a piecewise function. One is y equals -x, and if you look at this right side, That's y equals x. So this is the absolute value function. I typed it out here as ABS of x, but I think I could have done this. It's when x is in the straight lines, you just take whatever x is and take the positive of that value. So when x is 5, y is just going to be what x was, because x was already positive, it's going to be 5. But when x is negative 5, the absolute value of -5 is still 5, because it's still 5 away from 0. So y becomes 5. So that's how you get the slope of -1 here and the slope of +1 here. So an absolute value has a vertex that is a sharp point, unlike x squared, the quadratic function that had a vertex at a rounded bottom. So recognizing absolute value of x as this shape will be important. Now we looked at x squared. This is x cubed. If you look, this does have negative numbers in its range. When x is negative, if you multiply a negative number by itself 3 times, and that's what the 3 means, a negative times a negative is a positive, and then you take that and multiply it by a negative, you get a negative. Anytime you have an odd number of negative numbers being multiplied together, then you get a negative as your result. That means for all negative values of x, x cubed gives you a negative value for y. It gives you a positive value for y when x is positive, and it's steeper than x squared. If I put the x squared back there, you see x cubed rises faster. So that is x cubed. Its ends go in opposite directions. That becomes very important later too. So now let's look at the square root of x. I don't have any x values plotted to the left of the y-axis over here. That's because I can't take the square root of a negative number and get a real answer. These graphs only show us real values of y that would occur, or real values of x that we can put in. And if I asked you the domain of this, you can pretend there's an arrow there. It starts at 0. X is greater than or equal to 0. Those are the only points I can plot to make this graph. I don't have any points to plot when x is negative. So this is a square root function, and if you take the square root of 4, you see you get 2. And we're going to learn later that this is the inverse, in a sense, of the right. It is the inverse of the right half of the x squared function. X squared does not actually have an inverse. Okay, this is y equals the square root of x. The next function is y equals the cubed root of x. Now look at the difference. This red function was square root, and it doesn't have any values above or below where x is negative. But the cube root of x does. If x is -8, I get -2. You can see that right there where I'm pointing to. For y, and that means -2 times -2 times -2 must be equal to -8. This is why we don't have a domain restriction when we have an odd root, because you can multiply three negative numbers together, or 5 negative numbers together, to produce a negative number inside. So the cube root of x as domain all real numbers. So it's kind of got this squiggle. It's almost like x cubed rotated, which it essentially is. All right, so those are the graphs of your 7 common functions. Square root is there, x cubed, and let's look at x cubed with its cube root. They are inverses of each other. That's why you get this symmetry over y equals x. We'll talk about that more later. And then the absolute value, and then the basic quadratic, the identity line, and y equals a constant, or f of x equals a number. This happens to be 3. If I make that 5, it just changes the location, but it's still a horizontal line. That's it for today's video. Please work on memorizing the shapes of these functions. But if I only look at, sorry, I don't know what happened there.